Good morning. Today we are going to work on lesson 6-9. So our math message for today is to solve the problem at the top of the journal worksheet, page 219, and it says Tori has 8 blocks. Each block is 1 2/10 centimeters high. If Tori stacks the blocks, what will the height of the stack be? Pause the video for just a minute and try to solve that problem. Once you've solved it, go ahead and press play and continue on with the video. One of the strategies that you could have used is to do repeated addition to solve, adding 1 2/10 8 times. Oh, hang on. So when we'd add those all together, it would look something like this, except it would all be in a straight column, and you would get 9 6/10. The other method that you could have tried is to multiply the whole number part of the decimal, which was 1, times 8, which would give you 8. And then you could add 0.2 8 times. So 0.2, 0.2, 0.2, 5, 6, 7, 8. And that would give you 1.6. Then you can add these two numbers together, 8 plus 1.6, to get a total of 9.6. How would you make an estimate for 1 2/10 times 8? The answer 9.6 would make sense because you would estimate 1.2 to be 1, and then you would leave the 8 and 8, so that would give you an estimate of 8. So then it asks, does the answer 9.6 make sense based on this estimate? Yes, it does, because 9.6 is close to the number 8. So today we're going to develop strategies for multiplying decimals that are based on what we know about whole number multiplication, estimation, and powers of 10. Look at the problems that are on the left side of the page. You can see that when we multiply each of them, we can see that the answers have all of the same digits in them, 3, 0, and 8, but the decimal points are located in different spots. So they differ only in where the decimal is placed. Now look at the problems on the right side of the page and take just a minute, use your calculator and solve each one and jot down what your answers are. Once you have done that, I will show you what the answer should be. So 1.2 times 0.8 is 0.96. 1.2 times 8 is 9.6. And 12 times 8 is 96. Now, what do you notice about the factors in all three problems? Well, the first thing that you notice is that they all have the same digits in the same order, but the decimal point is in different places. What do you notice about the products of all three problems? They all have the same digits in the same order, but the decimal place, or the decimal point, once again, is in a different place. Now, do you think that this pattern is true for all multiplication problems with factors that have the same digits in the same order? If you wrote down 3 multiplication problems with factors that have the same digits in the same order, but the decimals in different places, you will find that the pattern holds true. Since this pattern is true for all multiplication problems, one strategy for solving decimal multiplication problems is to multiply the decimals as if they were whole numbers, and then use an estimate to place the decimal point. For example, we have 6.8 times 2.1. So the first thing that we want to do is make an estimate. So to do that, we could round our 6.8 up to 7 and round our 2.1 to 2. So our estimate is going to be 14. Next, we're going to multiply these factors as if they were whole numbers. So we would multiply 68 times 21. Notice I don't have the decimals in place. When I do that, my answer is 1,428. Now I'm going to use my estimate to put the decimal point in the right place. So my estimate up here was 14, which means that it makes sense to place the decimal point between the 4 and the 2. So my actual answer would be 14.28. You could even double check yourself with a calculator if you'd like, and you'd find that 6.8 times 2.1 is 14.28. Go ahead and try to work out the problems on your math journal sheet, page 219. There are 3 of them on there. So let's go over these together. Number 1 was 76.1 times 9.6. We're going to make an estimate first. And let's make our estimate for 76.1. We'll make it 75. And then for 9.6, we'll make that 10. So 75 times 10 is going to be 750. That's my estimate. So then I'm going to actually multiply the numbers together. 761 times 96 is going to give me 73056. So then I look back at my estimate, which was 750, so I'm going to put my decimal point right here to make my answer 730.56. That's fairly close to 750, so that makes sense. Number 2, the problem is 189.6 times 1.75. So for my estimate, I'm going to round 189.6 up to 200. And I'm going to round 1.75 up to 2. So that will make my estimate 400. Then I'm going to actually multiply these numbers together like they're whole numbers, which would make it 1,896 times 175. When I do that multiplication, I get an answer of 3318. Now I'm going to look back up here at my estimate, which was 400. So where can I put that decimal to make it fairly close to that number? I'm going to put my decimal right here between the 1 and the 8, which will give me an answer of 331 and 8/10. For number 3, we have 5.6 times 0.8. So my estimate for 5.6 is going to be 6 times my estimate for 0.8 is going to be 1. So 6 times 1 equals 6. That's going to be my estimate. Then I'm going to multiply those numbers like they're whole numbers. 56 times 8, which would give me 448. But I know my answer has to be close to the 6 up here. So I'm going to put my decimal point right here between the two 4s to give me an answer of 4.48, which is close to 6. There are times when making an estimate is not helpful or even practical. If we had the problem 0.073 times 0.02, why would it be difficult to make an estimate for this problem? The problem is that it doesn't make sense to round either decimal to a whole number, so we'd still be multiplying by a decimal. So, for this problem, would you expect the product to be greater than or less than 0.073? You would expect it to be less than this because the other factor is a number which is smaller than 1. So this factor here is less than 1. Remember in the previous activity that we ignored the decimal point and multiplied when both factors as if they were whole numbers. So how would we rewrite 0.073 times 0.02 as a multiplication with whole numbers? We would just write 73 times 2. How many places and in what direction did we move the decimal point to go from 0.073 to 73? We would have moved it 3 places to the right. So that would that be 1,000 or 10 to the third? How many places and in what direction did we move the decimal point to go from 0.02 to 2? We moved it 2 places to the right again. What could we multiply 0.02 by to move the decimal point 2 places to the right? 100 or 10 to the second? So I can show you that when you multiply 73 times 2, your answer would be 146. Now, since we didn't estimate the answer to the problem, we can't use an estimate to determine where the decimal point goes. Instead, we're going to undo the changes that we made when we changed the factors to whole numbers. So when we changed 0.073 to 73, we multiplied by 10 to the third power, right? How can we undo that? Well, we can divide by 10 to the third. So we can move the decimal point 3 places to the left. So that would move this decimal point here for 146. It would actually be here, so we're going to move it 3 places to the left. So now it would be here. Then we also changed 0.02 to 2. We multiplied by 10 to the second power up here. So to undo that, we're going to divide by 10 to the second. If we divide by 10 to the second, we're going to move that decimal an additional 2 more places to the left. Put some zeros in here. Okay, so the result is we get an answer that is 0.00146. So we move that decimal. This was our answer here that we got when we multiplied those numbers as whole numbers. We moved that decimal point 3 places to the left and then 2 more places to the left. So we ended up with our decimal right here. So let's go ahead and summarize what we did here with this multiplication strategy. First, we multiply both factors by a power of 10 to make them whole numbers. We keep track of both powers of 10s, or the total number of places the decimal point shifted in both factors. Then we multiply the whole numbers. That's this step right here, where we did 73 times 2 and got 146. Then we undo the multiplication by powers of 10. So we divide the product by both powers of 10, or shift the decimal point to the left by the total number of places it shifted when changing the factors to whole numbers. Okay, so let's do this problem together. We have 12.6 times 2.75. First of all, we're going to multiply both factors by a power of 10 to make them whole numbers. When we do that, we're going to keep track of our powers of 10, or the total number of places the decimal point shifted. So first, we're going to multiply 12.6 times 10 to the first, which will now give us 126. It's going to move that decimal place over one spot. And then we're going to take 2.75 and we're going to multiply it by 10 to the second, which will give us 275. Next, we're going to multiply our whole numbers. So now we're going to multiply 126 times 275, which will give us 34,650. Now we have to undo the multiplication by the powers of 10. So first we would divide by 10 to the first, which would shift the decimal point one place to the left. So that means we started here, we're going to go one place to the left. It's now in that spot. Then we're going to divide by 10 to the second power, so it's going to shift it two more places to the left. So 1, 2. So I need to shift the decimal point a total of 3 places to the left, which will give me the answer of 34.650. Now, you can go ahead and complete the problems on page 220, and then you are going to use this strategy to do those. And when you do the problems on that page, you're going to notice that they are just like the problems that we did before, but we want you to try the different strategies on each page. Once you've completed that, then you have HomeLinks 6.9 and MathBoxes 6.9 to complete and submit in your module.